Can you all hear me? Can you hear me okay? Anybody? I hope so. Can you hear me or not? Anybody?
Loud and clear.
Okay. I'm making sure nobody's got their face up, but that's okay. All right. Yeah. And if you can turn on your cameras, it's be appreciated. Okay. All right. Can everybody see the screen I've shared?
Yes, sir.
All right. Now, first thing I try to do is take questions about problems. Does anybody have a question about any of the problems I've assigned or any other problems at all? As a matter of fact, before we do that, I want to do one thing based on a question I received from somebody who was a little unfamiliar with complex numbers. And believe me, there is no dumb question or dumb questions. Just ask away. And if it gets too much in class, you can ask me offline. So what I'm going to do is shut that down for now and go to my document camera, hopefully. And I want to do one thing with complex numbers because a lot of people haven't probably used them day to day yet. When you have a complex number in general, and I'll just label it A, there's a real part and there's an imaginary part. I hope everybody can see this okay. Now, graphically, if you talk about this, it looks like this. This is the real axis, and this is the imaginary axis right here, or the J-axis. And when you have A plus JB, A would be on the real axis. That's just a point there, just like an XY plot in a graph. And B could be plus or minus, but I'm going to assume it's plus, would be here, or JB. And this would be the actual graphical representation. It would be the magnitude of this, which would be equal to the square root of A squared plus B squared, would be the magnitude. And the angle would be theta. And in polar form, this is the polar form I'm putting on next, would be the angle theta. Now the angle theta can be gotten by taking a tan to the -1 or inverse tan of the opposite B over A. And I'm doing this very simply. I think most of you know this. The nice thing is your calculators will do this. Do you agree, class? Just give me some indication if you understand complex numbers and what I've shown there. Got one. I'm hoping everybody's on. I know probably other people are looking at this and walked away because it's something they understand. I'm just making sure everybody can see this and understands what I've shown, correct? People? Yeah, okay. Now, a question was asked, well, how do you do division and multiplication? I preferred to work with polar coordinates, just have magnitude and angle. So if we have polar coordinates, let me just do this. Suppose I wanted to know what A, I'll give you a concrete example, is A over B is. And say A had an angle of theta 1, and then B has an angle theta 2. A and B are simple magnitudes. Well, that's really just A over B. And then the angle, if you're dividing, you take the upper angle and subtract from it the lower angle. So it would be at an angle of theta 1 minus theta 2. Are you with me with that? Class? I'll give you a concrete example of this in a second, but your calculators do this seamlessly. Okay, everybody? At least you see what I'm doing and you understand it, correct? Okay, thank you, Jess. I think I got one affirmation. I hope you can at least see it. 2, thank you. All right, now if you're doing multiplication, if I have A at an angle theta 1 times B at an angle theta 2, that's just the magnitude of A times the magnitude of B. Or actually, now A and B don't have to be positive, and if they're not, if they could have a plus or minus value, that wouldn't be true. So I'm going to just put, it would be A times B. Those are scalar numbers. It could be 1, it could be -1, it could be 20, -20, and so forth. The angles are what you deal with here additively. It would be theta 1 plus theta 2. All right? How many knew that before, by the way? I assumed everybody knew. In calculus, and I think in your mathematics courses you've had it. Just a show of hands, if you've had this or you've had to use it. You've had complex numbers in calculus, right? Everybody here should have, at least that's what it says on the prereq sheet. Okay, good. Now, a real example of this is suppose I had, and use your calculators if you got them. Suppose I had 10 at an angle of 30 degrees, now I'm putting that in degrees, divided by 5 at an angle of minus, say, 20 degrees. What's that going to be? Well, how do you get the magnitude? What would I do? It would be 10 over 5, correct? And what would the angle be, class? It would be 30 degrees minus 20 degrees, correct?
Yeah.
Are y'all see? I'm trying to make sure I'm getting through to you because I got a question about this, and I assume whenever I get one, there's usually a whole bunch that won't ask. Either they're ashamed or they frankly just are too busy. So this would be equal to actually 2 at an angle of what? 50 degrees, correct? Are you catching on to this? Now your calculators do this. If you have problems with your calculators, please put it information out there on the GroupMe page or send me something and I'll send it to the whole class and try to help one another. Please don't be selfish or stingy. Everybody needs help sometimes. And so we're all in this together, as they said. Now, I'm done with that. Now I'll entertain questions about any of the homework, and I have an agenda too today if there are no questions, but I prefer to try to answer questions. Anybody? It's rare for me to start a lecture and not get at least one question in a class this size.
Can you do number 33?
Yeah. I'm going to make sure everybody can see this. This should be in OneNote. All the problems are on OneNote. So this is 33, right? Oops. All right. Hang on. I'm just getting the actual thing I gave you. There's 33. Y'all see it? Can you see it okay from your computers? Don't use phones for this class because I don't think, unless you got a giant one, I prefer you use laptops or PCs. All right, for problem 33, they want nodal equations, and I'm going to draw this in here. So I have a current source of 6 at an angle of 45 degrees. This is a good one too. And then I have a resistor, and that resistor is 2 ohms. I'll blow this up a little. And there's a current here that he labels, that's what he's after, I naught, right? I naught. And then it has a capacitor, but it gives you the capacitive reactance, which is nice, so you don't have to calculate, as minus J4 ohms, right? I'm going to omit the ohms, and then it has a J2, and then it has a voltage source. I got a comment about this one. And it has 10 at an angle of 0 degrees. And it says use nodal. Now here he puts in a ground. Not all the time is that shown. And a ground means what, anybody?
Voltage is 0.
Yeah, the voltage is set to 0. It's the reference voltage, right? Every
Yeah.
voltage is measured with respect to that, correct, class? And then he labels this, oops, I gotta get back to my camera right here. I'm sorry, I drew this thing and I hope you didn't. I hope you weren't, you didn't understand what I was talking about. I just recreated the circuit. This is V1, right? And this is V2, correct, class? Now, before you just brute force everything, and that's sort of a gut reaction, everybody. Try to recreate something you memorized. Don't do that. Look at it carefully. I've got an unknown current here. I will have an unknown current here because it's nodal. And I'm going to label this current I1, okay?
You're out of focus.
I know. Thank you. I don't know why the camera goes out of focus. Probably my hand. Are you with me?
Yes.
And if somebody can keep me updated if there's something in chat that you that I need to know about, because chat doesn't appear when I'm looking at you with my screen at least. So here it's 0 volts and there's V1 and V2, correct? Everything's measured with respect to the ground potential, correct, class? Now, I know what you're thinking, but we should put a current here. We could call this I2. You're going to see you don't need that current. I'm going to show you something. Take a good look at this circuit. What is the voltage V2? Just by inspection, class.
10.
It's 10 at an angle of 0 degrees. How many see that, right? It's evident to you just by looking. Whoever asked this question, I hope this is clear to you what I'm doing here. You all with me on this? I don't know who asked it, but I hope, does that make sense to everybody? I'm seeing plenty of thumbs. Okay, good. So this is 10 volts. Now that means we have only one unknown, V1, correct? You agree with that?
Yes.
All right, I'm going to write one equation with one unknown, V1 ultimately, based on node 1 here. And when I look at that, I'm going to say the currents going into it are just 6 at 45. I'll put those on the right because I know that's going to be a known, right? And that's amps. And then the unknown currents are I0 and I1. Now, again, I assign these values. Well, I0 was assigned, but I assigned I1 as I saw fit, right? You good with this?
Yeah.
Now, to continue on, what is I0? Well, I0 is just V1 over 2, right? Because it's the other side of that resistor is 0, correct, class? Okay, so I0 is V1 right there over 2 ohms plus, and I1 would be what? V1, go ahead, minus 10 over minus J4, and that's equal to 6 at an angle of 45 degrees, correct? Now this is, you don't have to do it this way. This is one equation with one unknown, correct? I'm going to do something, and this is the way I do it. You don't have to do it this way. First thing I'm going to do is multiply everything by 4 first. So when I multiply by 4, the coefficient of this becomes 2, correct? And when you follow me, I'm multiplying the whole thing by 4. And when I multiply by 4, this 4 goes away, correct? Agree? All right. And when I multiply by 4, this becomes 24, correct?
Yes.
I know it's a little sloppy, but I want to make sure you see the progression, right? Now, at this point, you can multiply everything by minus j if you want. But I'm going to stop here. What is 1 over j? If I just have 1 over j, that's really equal to what? Anyone?
Minus J.
Right, minus j. So what's minus j equal to? Plus j, right? You agree with that? If you agree with what I've done there, give me some indication, either thumbs up or some, I need, okay, got 1, 2, 3, I'll take it as you do. If you don't, let me know. 4, 5, good. Thank you very much. It helps me. So that's plus j. Get rid of that and just put a j here. Do you all see this, class? Don't have to do it this way. I choose to do it this way. There's probably a whole lot of ways to solve this thing, all that lead to the same answer. Now, I'm going to go ahead and then gather the knowns on, or the unknowns on one side, which would be the coefficients of V1. So V1 is here, and I have 2, right? And then I have plus j, right? And then I have minus j10 if I multiplied the j through, correct? So minus j10 to the other side would be plus j10, correct? So that means on this side, I would have 24 at an angle of 45 degrees, and then it would be plus j10, correct? How many see this?
Yes.
All right, and again, this is something I think really boils down to your calculators in operation. Now, I can see that V1, therefore, would just be 24 at 45 degrees plus J10. J10 is really 10 at an angle of 9 degrees. I'm going to leave it as J10 divided by 2 plus J1. Correct, class?
Move the paper down.
Yeah, thank you. But really, the only thing I'm doing is dividing the other side by 2 plus J1, or 1J, correct? Here's where getting familiar with calculators is going to help you. Amount
Not
of paper.
sure. Where did you get the J10?
All right, if you see J times minus 10, that would be minus 10J on this side, right?
Yes.
If I added plus J10 to both sides, it would cancel this and plus J10 would appear here. You agree?
Yes.
Okay. So that's how I got that. Now I need to go to another piece of paper, but everybody has that equation, correct, class? This is where your calculators, when you get to use them, will make this trivial. You can plug this right in, but I have V1 is equal to, and it's 24 at 45 degrees. Now 24 at an angle of 45 degrees, I know is going to be 24 over the square root of 2. Your calculators will do this for you. I'm just putting it in. And 1 plus j. I know that when I have 1 at an angle of 45 degrees, that's really 1 over the square root of 2 plus 1 over square root of 2 times j. I know that for a fact. Plus j10 all over 2 plus j1. Here I'm going to say one thing. I know this was actually 24 at an angle of 45 degrees, right? Your calculators, and I don't know everybody's calculator by heart or how to do it, your calculators have a way of entering either polar numbers or rectangular complex numbers with the real and imaginary parts. They'll have either one. I'm not familiar with your calculator, so I can't tell you how to do it, but I know TI 83, 84, 89, 93, Inspire, all do this. I've taught this class many times, but I don't I'm sure they're very similar with 83 and 84. 90 or 89 and 93 are probably similar, and I'm assuming Inspire is. And does anybody have a calculator that is not TI in here? If you have a Casio, somebody did, right? James, you do? You got a Casio? Anybody else? If you got a Casio, I'm sure you can look it up. You can figure out how to do this, how to enter complex numbers or polar numbers into your calculator. Now, I can go ahead and I'm using Octave, and it's probably very similar to a lot of your calculators, but I can't say that for sure because I don't know your calculator. If I go to my thing with Octave, you can find Octave right here, and I go ahead and I say this is V1 equal to, and then it's going to be, I'll put it this way, 24 divided by, what is this? Square root of 2, right? It's that times 1 plus 1j plus j10, or plus 10j, I think we'll do it. And then I'll put brackets there. And then I'll divide this whole thing. Do this in your calculator if you don't know how to yet. 2 plus 1j. This will save you some time. Now, if you do that, you should get this, and that's in terms of a real and imaginary component. In terms of an absolute value or a magnitude, it should be this, right? And then it should be it's angle, I think here, angle. There's probably a function that'll do this for me too. And that would be degrees. Y'all agree with this?
Dr. Baginski, would you mind explaining how you got the 24 over the square root of 2 thing?
Yeah, you know, when you have one at an angle of 45 degrees, right? What this really is this. It's 1, and this angle is 45 degrees, right? That's the real axis, A, and this is the imaginary axis, B, correct? You see what I'm doing here? I'm just showing you a right, I'm showing you 1 is the magnitude, and there's 45 degrees would be the angle. This would be the real axis, right? And this would be the imaginary axis. Do you follow me?
Yes.
All right, now what is this? Well, A is what? A is equal to this magnitude, or 1 times the cosine of 45, right? And what is this? This is plus j times the magnitude, which is 1, times the sine of 45, right? And what's that? Isn't cosine and sine of 45 both 1 over square root of 2? And I just put 1 plus j here. Now, you can enter this right in your calculators. You could put 24 at an angle of 45 right in your calculators, so you don't have to know this. What kind of calculator do you have?
Just the regular TI one.
I mean,
Yeah.
a number on it, 89, 84?
I think it's an 84.
An 84, anybody have an 84 and know how to do this? Anybody?
I have
Okay.
an 83, but I shared a video, and I think Amanda also shared a video on YouTube on how to do this.
Jessica, I don't know who told me, but 83 and 84 have the same functional keystrokes.
Yes. There's video on YouTube. I shared one on the chat, and I think Amanda shared one too.
Can you send it right to Gabriel?
Let me see.
I saw her send the video earlier. I can just go watch it. Thanks.
Sure.
Okay.
All right, but what I'm really getting at is if you don't know how to use your calculators, now is the time. You've got people here that can help you. All right? Because trust me, in this class, no matter how much I yell about knowing to use your calculators, there will always be somebody that says, I don't know how to do this on my calculator. I've given you fair warning. You have to know how to use the calculators the calculator you're using efficiently in a quiz. I can't be any clearer about this. And I appreciate those questions because a lot of people ask me, how do I do this on my calculator? I don't know, but somebody out here does, I have a feeling. Okay. Now, when I do this, getting back to what I was trying to get at is this. That's what I got for the magnitude and the angle. And this is the real and imaginary part. Now I'm just asking you, please, pleading with you to do this on your calculators. How many got that? How many got this? A thumbs up, something. 1, 2, 3, 4. Anybody else? Nobody? Somebody put this in chat. I appreciate it. And I thank you for that. Help each other out because believe me, you're helping yourself in the long run. All right, now what did they want in this problem? Let me go back to the problem. They wanted I naught. How do we get I naught if we have V1? Anyone? Anyone at all?
I naught is just V1 over 2.
Does everybody see that, please? All right, if we got V1, we divide it by 2 because on the other side is 0 volts, right? Normally, you'd have to take V1 minus the other side of the voltage on the other side of the resistor and divide by the impedance, or 2. Any other questions about the homework? And I appreciate that question, but this was a very This is a problem you should be able to get in about 1.5, 2 minutes. The only thing you had to do is recognize V2 is 10 volts. And then from there, it's one single equation with one single unknown. And entering this information in your calculator should be very efficiently done. You shouldn't stumble around and wonder. You should be doing this, okay? I'm trying to just encourage you to do it. I'm not trying to threaten you. No matter what I do, it doesn't seem to always work for everyone, but I'm trying my best. Anybody else questions?
Yeah, I have a question.
Okay.
Can you walk through how you got the open source voltage on 460?
460?
Yes, sir.
Okay, hold on. This one. This one?
Correct.
All right. All right, I'm gonna, it says use Thevenin, so I'm gonna go ahead and, how about this, guys? How about we make this efficient? Now, y'all see this, right? Here's what I'm gonna do. I'm gonna say the load is 1 ohm. Do y'all give me that? It's where the information is wanted. It's I naught, right? So the load is 1 ohm, agree? Don't worry, I'm leaving it there. So RL is 1 ohm. Now, the open circuit voltage would be with that 1 ohm removed. Who asked this, by the way? Anyone? Who asked this question? Joseph?
Yes, sir.
Okay, thank you. All right, y'all agree we're going to remove this 1 ohm. Do you agree with me? Right? To find the open circuit voltage. I'm going to draw it, but I think you can see, if you remove this here, just think about it. If this is gone, doesn't this 2 amps have to flow through this minus J1 capacitor? How many say that? Think about this. If this is, maybe I better draw this, but if you remove this resistance, then all this current has to go through minus J1, right? Now, let me go ahead and do this one on, I'm just gonna first start with the load being 1, and then I'm gonna show you. I'm gonna put this down, hopefully, or pull up this camera. And I really wanna do my best to show you this. And so this is 460. So it has 2 amps, right? And that's at 0 degrees, just 2 amps. And then it has, here's where the load was. I put RL as 1. Hopefully you can see it. And this is plus to minus right there. And this would be V open circuit. And then it has minus J1 here, right? And then it has 4 amps at 0 degrees, and it has J1. Oops, sorry. This is J1 here. Ohms here, and then it has a source of plus to minus 6 volts, and I'm sorry. I'm trying to do this efficiently. This is going to be plus to minus 6 volts at 0 degrees. So just 6 volts. And then it has 1 ohm here. You can look in your notes set or on OneNote if you don't know if this is 1 ohm. And then it has 1 ohm here. That's it, right? And you can forget about that. This is plus to minus 6 volts. Agreed, class? With what I drew? Y'all see it? Just looking for, I'm trying to interact with you so I know that you can see and hear what I'm doing. Are you good with this, guys? I got 2 thumbs up. I'm assuming you are. All right, now look. How much of this 2 amps can flow this way? Anybody?
None of it.
None. It's 0 current flows there, right? It flows here, right? Now here's the thing that's probably causing you some angst, and I'm going to try to be clear about. When you're talking about a voltage across any impedance at all, and I'm doing this on purpose moving down here. So if I just have a black, something where I don't know the impedance, just call it Z. Z could be R, it could be J, J omega L. It could be minus J over omega C. It doesn't matter what this is. No matter what that is, if you have a current I flowing into it, and I can be complex, it will develop a voltage across here, plus to minus. And that voltage across here, plus to minus, will be equal to Z. Z can be complex or just strict real, times I. Now that's as much as there is to that. So the voltage developed here, right there. I'm sorry it's out of focus. Hopefully it'll come back in focus in a second. Come on. All right. That voltage plus the minus here would be equal to the current through here. And you see that through there is 2 amps, right? Times the impedance, which is minus J1. Now, think about this. I said the voltage is Z times I, plus to minus. That means the voltage here would be Z is equal to minus J1 times I is 2. Correct, class? You don't like that, but that's as simple as it gets. It's the impedance minus J1 times the current 2. Current has no angle. That means this voltage, and I'll put it down here, would be equal to minus J2. Are you with me? That's all it is. It is in volts too. Minus J2 can be rendered as 2 at an angle of minus 90 degrees. The minus J tells me it's at minus 90. If it was plus J, it would be at plus 90. Okay? Now you asked about the open circuit voltage. I'm not sure Joseph or somebody did. Take a look at this. If I want to find the V open circuit here, I know that this voltage is what? Minus J2. Now, if I have minus J2 here, watch this. If I have minus J2, it means this voltage right here, plus the minus, it is equal to minus J2. Isn't that identical to saying, in fact, that was plus, that was minus, making this minus and this plus, and making that plus J2. Take a good look at what I just put down. How many see that? It's just like if you have minus 10 volts plus the minus, you switch the leads, you get plus 10 volts. Correct, class? How many see that? Okay. Some very reluctant thumbs. I'm hoping I'm making my point without, I'm not trying to insult anybody. I know I'm going to get an email about this from some ME pro. But I'm trying to make sure you all see it. All right, class? Now, that's the case. What can I do with this? I had plus to minus. I can do what? I can get rid of that, rid of that. Remember, it's voltage. So it would be, instead of plus to minus, this would be plus, this would be minus of just J2 volts, right? Or you could put it 2 at 90 degrees. Do you agree with that? Either one. But what is
Can
the
you put the
open
paper up?
circuit? Yeah. Sorry. This is, I simply flipped it. Before it was plus to minus, minus J2 volts. I made it plus J2 and I put the plus here. Move them, okay? All right, so what is V open circuit thing, guys? I told you to start at the negative terminal. I go around. You see this is a voltage increase of 6, correct? So it's an increase of 6. Then what is this? A voltage. I started at the plus, came out the net, a voltage decrease of J2, right? So it's minus J2 volts. Did that answer your question?
Yeah, that's it. Thank you.
Now you can put it in polar form, but this is essentially all you need. And let's just finish this because you asked the question. This is a great problem. And this is a typical problem that if you know what you're doing, you'll do it real quick. And if you don't, you'll get in some bizarre kind of thought process to figure out how do I include this and this and this. You don't need that, right? So we got the open circuit voltage. I'm going to draw it here. This is my Thevenin circuit. Forgive me for moving a little fast, but this is going to be the Thevenin equivalent circuit. Come on. And it has an open circuit voltage here, plus the minus 6 minus J2 volts. That's the open circuit voltage. Now we need the Thevenin equivalent impedance, right? So for the Thevenin equivalent impedance, that's across these terminals, right? What do? We turn off the sources. And what happens to a current source when you turn it off? Anyone?
It's a short circuit.
What's the other option?
Open circuit.
Yeah, when I say turn it off, think about it. If current goes to zero, only if you take the element out, right? It's in an infinite impedance or an open circuit, right? Literally, this isn't there. You with me? Okay, you turn them off. Current sources become open circuits. And remember, what am I after? I'm after this impedance, right? Correct, class? Now, this is a voltage source, correct? I know it looks like a resistor, but it's actually a voltage source, isn't it? Right here. What does the voltage source become? Now you can say it.
A short circuit?
Yeah, it's a short. That's a short circuit. Now take a look at this. I got a short circuit, I got an impedance, and if I look at the impedance across these three terms, this is an open circuit, you ignore that. I just have what? Minus J1 ohms between here and here, don't I? How many see that? Now, none of this stuff matters because that's a short circuit. So all this stuff, the impedance between here and here is zero. I can put any value of resistance across that and it's still 0 ohms. Do y'all see that? It's a short. All this stuff has no bearing at all on the open or on the Thevenin equivalent impedance. How many see that now?
Are you measuring from the positive to the negative?
Yeah.
For this one?
And you're looking at the impedance, right? Now, that's a short where that current source was, right? Can you hear me? If that's a short, just look here. I'll try to show you. And I'm not going to write my book this time, hopefully. Come on. If this is a short circuit and we're going between the plus and minus, that resistor is not there. That's a short. You see, you just have minus J1 ohm between this terminal and this terminal. For that to be reduced, there would have to be a resistance across that or some impedance because it's in parallel. Does that help? How many see this now? I don't see one. Hopefully you do. It's not meant to be tricky at all, not in the least. The impedance between here and here, without a short circuit, is just J minus J1. Remember, if that's a short circuit, all this stuff has no bearing on the impedance from here to here. It's 0, right? And look, you're at the negative terminal, or you're at the other terminal. Started here, go here. It's just minus J1. Take a good look at that later. It should be apparent. All right, so we have minus J1. Now we're going back to the actual circuit. So I have an impedance of just minus J1 ohm. Here's where I put my load. My load was what, guys? Anyone?
1 ohm.
1 ohm. And what were they after? They were after the current, but it's going to be the same as the voltage and magnitude. What would the current be here? It would be what? The source voltage, do this on your calculators, please, minus J2, divided by what? The series impedance, right? And the series impedance is what? 1 minus J1, right? How many see that? John U.S.'s question, does that make sense to you?
Yeah, that's good.
Or whoever asked it, Joseph, I don't know who asked it. All right, I'm going to go ahead and do it just because I want to make sure everybody sees this and gets the right answer. Get your calculators out. Please try this with me. And you should get a value of I equal to, I'm not using MATLAB, this is Octave, but the same functions basically are there. Minus 2J. And it's divided by 1 minus 1J. So that's the, and I can get ABS of I. Okay. And then I can get the angle of I times 180 divided by pi. And that would be the angle, 26.565 degrees. Now, how many see this, class? Got it? Got it? I mean, something, a thumb, anything to show that they got it. All right. And that's generally the easiest way to do a problem is with Thevenin. If there's a singular thing you look for, if you're just looking for voltage or current across one element. In my opinion, it's the go-to thing if you're given a choice, okay? All right. Another question. I'm trying to just flesh out anything with complex numbers. Ultimately, let me make one comment. What you really do, since this is steady state, this is something at a continuous frequency. I mean, the frequency never changes. It's like the voltage out of the wall. What you're doing is instead of using a, quote, resistance that's always a real number, you're replacing that resistance with a complex number, possibly. Now, instead of having just 10 or 100 or 1,000 ohms, you could have minus J10 or plus J10 or 10 minus J10. You follow me? That's the only difference. And then the calculations result in a magnitude at an angle. Okay? I promise you that's it. But people hate imaginary numbers because you're not familiar with them and they look funny. People are just unfamiliar with that. But when you work at it, you'll get familiar and know. How many have to use imaginary numbers or complex mathematics in your engineering courses? Now, MEs, I know you do. I mean, I know you've used Fourier transforms. You've used, anybody that's done Fourier transforms has done imaginary math, whether you like it or not. Are you with me? Okay. Now, what else do you have for me?
Doctor, just have a very quick question.
Yeah.
So I just realized that in the calculator, what you did was using absolute value and angle was going to radian mode, right? That's how you get the angle.
In octave, it'll go to radians. That's why I multiplied by 180 by pi to translate into degrees.
Right. So just wondering on the quiz, if we just using the formula of, you know, the B divided by A of inverse tangent, will you count that correct?
Well, if I ask for polar notation, and I'll probably say I want the angle in degrees, it has to be in degrees.
Right. What I'm saying is I will just skip the absolute value, then, you know, conversion. I can just input the like number 4 and number 2 for
What is your answer has to be in terms of a magnitude at an angle if I ask for polar. And that'll be standard with any engineering problems you get in the future.
Okay.
I mean, in other words, this isn't some specialized notation. It's only used in this course. You'll get this everywhere. You'll either get real and imaginary or magnitude and angle, I promise you. So that's what I'm getting. Now, more questions about any of the problems or anything you have as a problem. We've done one Thevenin here. We've done, we haven't done a mesh, have we? I don't think. Or did I do a mesh last time? No, I didn't. I did it maybe for some people. But we should do at least one mesh because it's exactly the same, only with complex numbers. So let's try one mesh. I know I gave you one. Mesh is the same thing as loop analysis, and 438 is a good one, unless somebody has a burning desire for another one. So 438 is here. You all see that? 430. Now here, this is kind of straightforward. You're only doing what? You're going to go in through and just write the equation, some voltages around this closed loop, then some voltages around this closed loop, set both equal to 0, right? And then solve. It's going to be a 2 by 2. But it's a complex matrix. That's the thing I got to get in your head. It's no longer just real numbers. So here, when I do this 438, make sure you do this because people will flub this up all the time. And remember, on these type of quizzes, the right answer is usually 50% of, because these are such shorties, there's only a couple of calculations involved. So you have to make sure you know how to do the problem correctly and get the right answer once you enter it. It's essential. So for this one, and again, I'm assuming you've got this before. Well, maybe it's a bad assumption, but let me put it up and then work it for you guys. So for 438 here, I have to write this down and you can see it. Y'all see that if you start at the lower left-hand corner, you're going to get plus 12. Agreed with that? I'll show you what I'm writing in a second. I have plus 12, right? Now you're going to get a voltage drop, a minus 1I1. Do you all agree with that? That's the voltage drop right here, correct? How many see that? Anything to tell me you're there and alive, right? All right, now the next thing I'm going to do is take a voltage drop across 1 minus J1. Just watch this. I'm going to say it's going to be minus the impedance, which is 1 minus J1. That's the net impedance, so I'm going to take that and put that as a multiplier of what? The net current flowing down, which will be I1, right? Minus I2, because I2 is flowing up, and the whole thing is equal to 0. I'm going to show you this equation before I solve it. That's the first equation. And then the second equation, now bear with me on this. Second equation starts at in the center right here, right? It's the lower left-hand corner where I2 is circulating. You agree with that? These are called submeshes, by the way. So here I'm going to take the net impedance, 1 minus J2. It's going to be a voltage drop. So I'm putting a minus there. So it's going to be a voltage drop. The net current flowing up is I2 minus I1. That's the voltage drop across these two elements, 1 minus J1. If I2 is flowing up, the voltage would be minus 1 minus J1 times I2 minus I1. And then this voltage drop is going to be minus J1 times I2. And then when you hit here, this is going to be minus 6 volts equals 0. Do you all agree with that? Minus 6 equals 0. That's the second one. Now I'm going to go to my other screen. I mean, where I'm doing this. So these are the two equations I'm left with, right? And now, and you do it the way you want. Now I'm going to separate things, put the knowns on the right and the unknowns in the left, and write it in terms of a linear, really a linear system, or call it, this is really linear algebra. That's all it is, only complex numbers. So here, I'm going to take, I like to do it this way. I'll take the 12 to the other side, makes it minus 12. Now this is me. You don't have to do it this way. When I see all those minus signs, I multiply through by a minus. You follow me on this? Now I gather the coefficients of I1 and I2. So this will be down here. I wish I could shrink this screen without this thing going out of focus. So when I gather the coefficients of I1, I can see I have 1 plus 1 minus J1, all right? So that's going to be 2 minus J1. Right? Then I gather the coefficients of I2, which is minus 1 minus J1. That's the first one. It'd be I1, column vector, I2, equal, and over here it's 12. Might as well fill in the bottom in a second. Now for this equation, the second one, I'm going to take the 6 to the other side. Can you all see what I'm doing here? It's just organizing. The 6 goes to the other side, plus 6, right? That's right here. And now I'm going to organize things. So I have I1 here. You see as a minus times a minus is a plus. So I'd have I1, and then the coefficient would be what? 1 minus J2, right? Then for I2, which is here, you see I have, I'm going to put the I2 as a plus here. I'm going to have minus J1 first. I'll write it like this. That's this one. And then for I2, because I put a plus sign here. It's minus minus 1, right? And it's minus plus j, or minus minus j2 or plus j2. I did this for a reason. Equals 6, right? Let's suppose that's j2 or 2j. Now you can see that this one really for I1 has the coefficients 1 minus j2. And the coefficient here for I2, if you look at it, is going to be what? Minus 1, right? And then it's going to be plus j. And that would be 6. Do y'all follow me on this, class? I'm just organizing things so I can solve it. You with me? Here you have to know how to use your calculators. Jessica, you have an 84 and 83. You can help people like that. The 89s do this seamlessly. The 93s and Inspires do it seamlessly. And I don't know about Casio. And if anybody else has an HP more, or an old HP or an Agilent or something else, I believe there's all modern calculators that are used for engineering analysis do this. Now, that said, now I solve for I1 and I2, and it's time's up. But I mean, you can follow me. The only thing I'm going to do is stick this in a solver and solve it, right? And if I use my solver, and you can check with, yes?
Dr. Baginski, you're going to post the video later because of the career fair, I also have to go earlier.
Yeah. And if you have career fairs, so be it. But I mean, what I should say to you, if you have to go, you go. I didn't give the quiz today because it is career fair. I wanted to go through the class, and now it's my office hour. So if you have to go. I hope I brought you to the point where you can come to your final answer. And the answers are in the solutions I provided, by the way. I want to tell you one other thing with this. Please, if you have problems using your calculators, interact with people on GroupMe or however, but this is the one time where other students can really help you if you're clueless. I mean, if you just bought a 93 or an 89, or you're using your roommates because you don't have one and you don't know how to use it, and your roommate makes no help. Now's the time to ask people. Please do so. I usually have everybody in class, and the people that don't know the 89s are all, or I mean, sorry, the 83s are all in one group, and the 83 and 84s and the other groups, I break them up. So I'm going to go ahead and just solve this, all right? Man, I got a lot. Hang on. No, you can't use Octave for the test, for the quiz. No, the quiz is just what you bring into class. You get a calculator, and that's it. No notes. I thought you were going to ask the phone a friend. Can we call somebody? No. All right. I'm going to go ahead and try to do this in Octave. So with Octave, I mean, your calculators is what you should use. If you're going, great. I'm going to do this. I always call the matrix A, just the standard. And before I had this matrix. So if you hit the up arrow, it will bring out back the last command you used with the symbol. In this case, it was A, capital A. So here, my first entry is 2 minus J1, or minus 1J. That's the first entry. And I'll tell you one thing, you want to do this if you're using Octave to check your answers or MATLAB. And the next one is on the top row is what? Minus the quantity 1 minus J. I'll put it in there that way. So it's minus the quantity 1 minus J. And then the second lower is 1 minus J, 1 minus 2J. And the final one is minus 1 plus J. That's A. The column vector was what, 12 and 6? Semicolon. 12 and 6. And that means my unknowns I are equal to and then I can get ABS of I, and then I can get angle. So what you should have got, if you're doing it right, now I'll ask for the answers in polar, would be a magnitude of 4.2426 and 9 for I1 and I2. And then the angle for I1 should be minus 45, and the angle for I2 is minus 90. By the way, for this one, 438, does this answer agree with what the book has or what the solutions manual have? I don't have it open. Can anybody check? Well, that's the way you do it. Let me ask you this. How many people using your calculators got the same thing? I got no hands. You got something different? Tell me what you got. I'm not hearing anybody or seeing anybody's response. How many people are still in here? 20 only? Okay. All right. Are we okay with this? Class?
I have a quick question actually about the I2 loop.
Yeah.
So you
Hold
got
on.
1 minus J2?
Well, look, remember, I'm taking everything as a drop if it's not a voltage source, right?
Mm-hmm.
So this is like one impedance, call it Z, the 1 minus J1, right? Just think of that as an impedance Z. So it's going to be minus that impedance minus Z times the net current flowing up, which would be I2 minus I1. Agree?
Okay.
So it's minus Z, which happens to be 1 minus J1 times the quantity I2 minus I1. Then it's minus J1 times I2, and then minus 6 equals 0.
Okay.
Remember, I'm taking these as drops. So drops require the current to enter the positive, the first terminal, and leave the negative, the last terminal over here. And I took this as a single element, the 1 minus J1.
Okay.
Other questions?
So I just looked at the solutions for this problem, and these do not match the answers you just got.
What do they have in the solution?
So it says I1 equals 3.78, and the angle is 18.44 degrees.
All right. This is for this problem?
Yeah, 4.38, right?
Hold on. Let me actually make sure about this, because I'm not saying I'm right, but I have a sneaking suspicion they're wrong. But I don't know that for a fact. Give me 1 second. That's 1, that's 1, that's minus 1, that's 1, right? Actually, what I'm going to do is this. I'm trying to do something here. I'm trying, no matter what I do, it ain't going to work the way I want to. But anyway, if I take a look at what I've done, so for equation 1, remember, this is the first loop, right? Ooh, with me?
Yes.
All right, so that's going to be an increase of 12. Actually, I had it here. It's an increase of 12. You know what? When that was an increase of 12 became minus 12, then it's going to be, unfortunately, I multiplied everything through. Then it's going to be a decrease of 1, minus 1 I1 here. And sorry. And then it's going to be minus 1 minus J1 times I1 minus I2 equals 0. Then when I multiply through by minus, get that. had a 12 here, became minus 12. This should be the first equation that they have in his solutions. Whoever, I don't have his solutions open, but whoever, Amanda, in his solutions, does he have this equation somewhere? Do you see it?
I see an equation, but it doesn't quite match up.
What's
So,
different?
yeah, so it says 2 minus J1 times I1. Well, that's
Yeah,
correct.
but that's
And
when you
then,
combine them.
yeah,
You get 2I1. That's right.
well,
Oh,
okay, so it has the same thing you put into the matrix,
well, then it's got to give me the same answer.
but it says the answer is wrong. Like it has a different answer at the end.
Does it have this matrix?
Oh, so
It's
the,
a little different.
yeah, so the I2 second part of the matrix, like the -1 plus J,
Yeah.
it has that as 1. And then it has -6 at the end.
And also the first term of the second column of the first row is -1 minus J.
Let me
So
look
the
at,
second,
-1 plus J, really.
the whole second equation is different.
yeah, but if you multiply through by a -1, that'll account for a lot of it. The -1 plus J is the thing I'm going to take a look at, see if there's a mistake in the book.
And he doesn't have the J2, he has J1.
Here?
Mm-hmm.
All right, let me take a look at this. All right, for the second one right here, it's going to be minus the quantity 1 minus 1J, right, times I2 minus I1. And then it's going to be minus J1 right here times I2, right? You see the loop here?
Yes.
All right. It's going to be minus this impedance, which is 1 minus J2. So it's minus that impedance, 1 minus J1. And that's net current flowing up is I2 minus I1. All right. Then it's going to be minus the second impedance is J1, right? And it's just times I2. And then it's going to be minus 6 equals 0. The only thing I've done, can you all follow me with what
Yes, so the difference here is it's J1 instead of J2. I think that's where we slipped up.
All right, well, I'm going to combine them. So for this right here, first I'm going to take 6 to the other side. Okay. Can you all see it?
Yes.
All right, that takes care of this. All right. Now, coefficients for I1 would be minus and minus is plus. So I1 would have coefficient 1 minus J1, right? Right there. 1 minus J1 times, because there's a negative times a negative is a positive, right? Can you hear me okay?
Yes.
All right, now when I have I2 has minus 1 plus J1, so it's minus 1 plus J1. This is going to be, that's I2 times this, right? Minus 1 plus J. And then it's going to be minus J. Actually, I did make a mistake. That's minus J, gets rid of J entirely. My bad. So this here, right there, that should be, for I2, it should be minus I2, right, equals 6. And if I go back, I appreciate you doing that. That's on me, and it's a typo. Let's see, where did I do that? And so that means this matrix right here is going to have 1 minus J1 right here. Right, this is going to be just 1. And then the second one is just minus 1. That's my bad. Are you with me?
Yes.
Then that, if I put that in for A, got B right. And that means I should be, oh, pardon me. I, and then the absolute value of I And then ANG of I times that. So those, is that the answer he has?
Yes.
My bad. I'm sorry. I did make a mistake in that. But you follow the trend, how to do it, right?
Yes.
And I'll tell you right there, that matrix, that complex matrix will cause more people problems. So what I would do if I was you, when you see a problem where you got two unknowns like problem 439, I don't know where else. For the voltages where they have two voltages, where's another one? Or 437, do those and make sure you know how to use your calculators efficiently to do them. Because I promise you that's a big headache that people don't want to address until the last minute and then they don't know what they're doing. Do it now, a days ahead of time. If you don't understand something, let the class know or let me know. I'll try to help you, but most of the time it's data entry. And it's very obvious once you see it, but when you don't, it's absolutely a killer. And I'm sorry if I'm saying it that way, but it's just the truth. All right. Now, any other questions? Because I'm trying to show you that we're really not doing anything more than what we've been doing, only with complex numbers. But the complex numbers are a headache and a half in your calculators. And I, for one, know that because I've taught this class so many times. And I wish I could tell you how to magically get this done for every calculator, but I can't. And I want to tell you one other thing. If somebody has a method or how to do it and it's efficient and it doesn't take long, just use it, because you're going to find that there's so much out there. You can spend probably days learning how to do it the most efficient method using an 83. Don't worry about this. Just find what works efficiently and use it.
I had a question.
Okay.
So I know you said earlier that for some of these questions, like we won't get a lot of partial credit because like
That's right.
the calculations and stuff. But on this first quiz, will we? Because we're still like learning how to do it in our calculators and stuff.
No.
Just checking.
No, but I'm going to tell you, just think about the first quiz you had with the first answer. Right? If you knew what you were doing, forget the calculators. It was obvious you got the right answer. If you hadn't established and understand, then you didn't know what to do. You're writing equations all over the place. It's the same way with these things. When you know how to do, use your calculator. It's seamless. It works the same every time and it's easy. It's when you're that gray area, well, kind of got it. He'll give me half credit. No, don't assume that. He probably won't. What I'm doing is forcing you to learn how to use your calculators now and not really just toying around with, well, I kind of know. Because kind of know doesn't work, especially in business. How many here are MEs? I'm just curious. Anybody? Of the people left. Anybody at all MEs?
Well, I'm technically materials, which I guess is under mechanical, but
Yeah, you're all right. So you take strength of materials, you take statics, dynamics, thermodynamics, right?
basically, yeah.
All right, well, then you know the importance of being exact in terms of buildings, and well, that's really civil, but in terms of getting exact numbers because, and no minus signs, because if you don't, buildings collapse, pumps blow up, everything like that. I wish I could speak more to industrial and processing engineers, but I tell you, I know people like Tim Cook could probably give me a very intelligent answer on how there's all these similarities between ME and I guess whatever he does out there in business, but there's not. Business is something where they look at ledgers and stuff like this, and a minus sign there puts you in jail when you try to doctor the books. In ME, things blow up and stuff like this. That's what I'm familiar of. When you design something wrong with high power, especially, either things burn down or they blow up. No matter what, you get fired. And that's why I'm such a paranoid person when it comes to calculations, if it's for real money, and when I'm trying to infuse this in you. Any other questions? I know this is the office hour. I appreciate your questions. I know that this is maybe not what you signed up for. If you're a materials engineer, Amanda, you're going to be doing a whole lot of stuff with complex numbers, I think.
We actually just started using complex numbers in one of my other classes today, so Maybe, I don't know yet, but seems like it.
All right, did I answer your questions? Do you have any further ones that need clarification?
I have a question on 4.60, the one we did in class today.
Yeah, hold on. Let me pull that up for everybody. 460?
Mm-hmm.
Do you understand the way I'm teaching with Zoom?
Yes.
That helps. Helps me. Go ahead. Or let me blow this up a little. Here's 460. Go ahead.
So when you were finding like the voltage, like the VOC, you got 6 minus J2. Is that just like, I don't super get how you got that.
That's all right. Just
Like I
listen
see
to
the
me.
voltage source and I see the,
All right. First, you agree that the 1 ohm's the load.
yes, that makes sense.
All right. Rip it out of there. Can you
Mhm.
imagine that? Now, y'all, do you agree the 2 amps has to flow this way? Has to go down here, right?
Mhm.
That means the voltage plus here and minus here would be the impedance minus J1, right? Times
Okay.
2 amps, right?
Okay.
Plus to minus, minus J1 or 2, or the plus on top to minus on the bottom would be minus J2 volts.
Yes. Okay.
Now, that's a voltage source. So if I go
Mhm.
from the negative terminal here, I get an increase of 6, then I get what?
You get the
I-
decrease. Okay.
Yeah, it's actually an increase of minus J2.
Okay.
That's it.
Okay. That actually cleared it up a
will,
lot.
that will bother people, I know. Help
Because I was
people.
like looking for like the minus J2 and I was like, where did that come from? But it's the, yeah, it's the, I get it now. Okay.
It will
Thank you.
drive, until you do a bunch of these, you will not feel good. And people that put this off, because next lecture is not going to center on this. Now we're going into transients. And transients are solving differential equations without solving them. It's the engineering way. You notice how we didn't solve one differential equation to solve this?
Mhm.
I thank God for that. I mean, I can do it with differential equations, but if you don't have to solve one, don't. Sort of that's the, in engineering, I don't know if you've ever have a course in how to do engineering and or like the real, I'd say the different, you know, if you know the difference between medical doctors and osteopathic doctors, they both do the same thing with the drugs and stuff, but their whole philosophy is different. MDs treat the symptoms, osteos supposedly treat the overall problem. It's a different philosophy. In engineering, our philosophy is not like physics. We don't want to figure out, you know, how this relates to this forming in the universe. The only thing we're trying to do is solve a problem in the shortest, fastest way possible with the tools we have and get the right answer. So in engineering, you have to appreciate all the physics, but you could care less of how it came. It didn't come down Mount Sinai with Moses. That stuff was discovered, and who cares where it came from? This is how you use it. So now what we worry about was the fewest number of steps to get the exact right answer and knowing what I'm doing. That's when it's called analysis. And really, but with synthesis, we want to know how to create things, to solve things, to do things in the fewest number of steps too. We don't want to spend a year to do something that can be done in a day with a calculator. And that's sort of the overall philosophy in engineering in general. And if you have a good teacher, you're an Emmy. If you have Birch, you'll probably say something profound about this. And oh gosh, I don't think Jeff Schuling teaches course, your Emmys guy. And I wish I knew more people in IE. There's 2 young guys there from East Bloc Nations. I'm trying to think of their name in IE that are really good, but I forgot their names. They're relatively new. Does anybody know? Are you IE, Brantley?
I'm Arrow.
You're Arrow. Well, if you're an Arrow, you guys got brilliant people over there. I mean, you've got Joe Majdalani. You've got who else? Roy. Oh gosh, I'm trying to think. All the Hartfield. Aerospace is loaded with some geniuses. So you guys got great people.
Well, thank you.
Any other questions? Seth, I can talk to you. If you got quarantine stuff, don't worry. If you're quarantined, you're quarantined. You don't need to come to the quiz. We'll get makeups for you when you're safe, okay? You there? Are you there, Seth? Thank you. Okay. All right. Well, I've got so much documentation in my email. When I get to it, I get to it. I'm not worried about people in my class. No mic. Okay. All right. Is that answer your question? You got any more questions? Okay. Can I go? Okay. Bye.